Okay, now the next part is electromagnetism. So let's say you have a normal wire. Let me go to here. So if I have a wire like this, and of course remember inside the wire you have electrons, and those electrons move around. But let's say right now I apply a current. So this becomes plus, that becomes minus. So the current always goes from positive to negative. What happens now is that this will create a magnetic field in that wire. So a magnetic field will be created. And the way we can describe that is we can call it concentric circles. So what that means is the magnetic field is stronger near the wire, and it gets weaker and weaker as you go further away. So that is concentric circles. But not only that, we can also predict the direction of the magnetic field. And to do that, we will use the Fleming's right-hand rule. So remember, the thumb will always point in accordance to the current. So from positive towards negative. And when you do that, you will see that your fingers will align this way. So in this scenario, if you use the right-hand rule, current goes up and fingers go this direction. So they'll go anti-clockwise. Now, if you were to flip the hand, so the current, or if you were to flip the current, so it points downwards, you'll see that the magnetic field will go in the opposite direction. So always remember, changing the current will also flip the magnetic field. Okay, now let's say in that wire that we had before, I take that and I start to coil it up into this shape. Now this shape has a special name. It's called a solenoid. So over here we have a solenoid. With a solenoid, remember that the magnetic field, it looks very similar to that of a bar magnet. Now also remember that you have these arrows here. So remember, arrow that comes in is the positive side of the current, and arrow that goes out away like this, that is the negative side of the current. Now when you see that, you also notice that the arrows for the magnetic field is being illustrated here. So the rule is this: whichever side is positive current, that is where the magnetic field leaves from. So it goes out from that direction. And the negative side is where the magnetic field enters from. So it enters from there. So it leaves from the positive side and it enters from the negative side. Now, how could you make this magnetic field stronger? And also they might ask you, which one is the strongest point? So it's strongest inside. As you can see, there are more field lines. So it's strongest there. As you go further away, it becomes weaker and weaker. But how could we overall increase the magnetic field? You can do three things. Number one, you can put more current. So increase the size of the current. The second thing you could do is you could twist it so there are more coils in your solenoid. The third thing that you can do is put a soft iron core. So take a piece of iron like that and put that inside it like this. So put a soft iron core. When you do that, by the way, now it becomes an electromagnet. Now the good thing about electromagnets is that the current can be turned on and off. The magnetic field can be turned on and off as you adjust the current. So you can use a switch to turn on the current and you get a magnetic field. Otherwise, what happens is if you turn it off, magnetic field disappears. This is useful in some situations. For example, inside factories where you want to pick up a car and drop it again.
Hey guys, if that video helped you, support our channel by liking, subscribing and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.